I think we're ready. I think I've gotten everything set up for this. I rebooted my computer actually, so things might be a little, just making sure everything's still up and running. There we go. Okay, so hi, welcome to the stream. Welcome to day 7 of Advent of Code. And as the days get on with Advent of Code, they get harder and harder, so we'll see how difficult this one is. Yesterday's was relatively easy. There's some code cleanup I wanted to do, but I don't know. Day 06 mod. There was some code cleanup I wanted to do with this and not use a loop, but I mean, this works fast enough. It's good enough. So I mean, you still have to do the loop for the cycles, but we should be able to just use an index to loop over these guys. And I don't know, maybe depending on how hard or easy 7 is, we can look at that. But let's get set up for 7 first. I want to make sure that cargo checks cache, or the quick list cache, is going to complain appropriately. So this should fail, and it fails. Good. So now if we edit source, oh, we have to make dir. Yeah, make dir source day07, and then edit source day07 mod.rs. I don't know why I did these in subdirectories. It could easily have just been regular files, println day07. But it is what it is now. Too late to change. I keep doing that because I'm a C programmer by day and a Rust programmer by stream. All right. So, oh, I did a test, not a run. There it is. Okay, day 7 is there. Okay, so I think we're all set up and ready to go. Let's see what day 7 has in store for us. The treachery of whales. Okay. A giant whale has decided your submarine is its next meal, and it's much faster than you are. There's nowhere to run. Suddenly a swarm of crabs, each in its own tiny submarine, because of course they are, zooms in to rescue you. They seem to be preparing to blast a hole in the ocean floor. Sensors indicate a massive underground cave system that's just beyond where they're aiming. Is this foreshadowing our roguelike? The crab submarines all need to be aligned before they'll have enough power to blast a large enough hole for your submarine to get through. However, it doesn't look like they'll be aligned before the whale catches you. Maybe you can help? There's one major catch. Crab submarines can only move horizontally. Oh, okay. You quickly make a list of the horizontal position of each crab. Your puzzle input. Crab submarines have limited fuel, so you need to find a way to make all of their horizontal positions match while requiring them to spend as little fuel as possible. For example, consider the following horizontal positions. This means there's a crab with horizontal position 16, 1, and so on. So 16, 1, 2, 0, 4. So no negatives. Each change of one step in horizontal position of a single crab costs 1 fuel. All right, that's simple enough. You could choose any horizontal position to align them all on, but the one that costs the least fuel is horizontal position 2. 16 to 2 gives us 14 fuel. 1 to 2 costs 1 fuel. 2 to 2 costs 0 fuel. All right. This costs a total of 37 fuel. This is the cheapest possible outcome. More expensive outcomes including aligning at position 1, 3, and 10. All right, so how, I mean, the naive solution, right, would just be to loop over all possible positions from 0 to 16, right, and then calculate how much fuel it would cost to get there, right? I'm worried that the naive solution would be too expensive for part 2. I don't know what part 2 is going to bring, so, but let's see if we can at least do that. So this is our input, and I'm going to do the same thing I did for the other day's solution, and just put the input right here rather than reading it from a file. All right, so what do we need to do? We need to split these up, and we need to know what. I think we can collapse these down, right? We can just say how many are position 2. We can say there's 1, 2, 3 at position 2, right? So it just means that if we're going to position 3, that means there's 3 that need to go from 2 to 3, which means they each cost 1 fuel, therefore 3 fuel to get to position 3 from position 2. I think that's the easiest way to model this, right? We have 1 at 0, 1 at 1, no, we have 2 at 1, 3 at 2, there's 1 at 4, 7, 14, and 16. I think that's all of them. Yeah. So I think what we can do is just collapse them down into a vector. Well, I don't know. Let's see before we do vector, what is our input? Oh, okay, yeah. And there's lots of big gaps between each. So this will be, I just double clicked and the whole thing went. How many numbers are there, by the way? Just out of curiosity. There's 1,000 numbers. So maybe like we did for the XY coordinates. Which day was that? We did XY coordinates. We can just use a hash map to store the positions. Escape. There we go. Go to the top. There we go. Use standard collections. Hash map. Right, and so we can just create a map of all of the positions. So we can just start here, let mute. I'm going to use a very descriptive name for my hash map. Hash map, and it's going to map the position with the number of entries, or the number of crab subs in that position. Let's call it crabs. Hash map new. Okay, and then we can loop over all of the entries. We can get the entries. Let subs equals test input dot split. All right, we've done this a few times now for this advent of code. It's just parsing out a list of. I'm going to make this a vec. 532. Parsing out a list of comma separated values. Collect all those. Okay, so now we have the hash map. Let's get rid of that day 07, and we're going to say for s in subs, what are we going to do? We're going to say crabs dot entry s or default plus equals 1, and I think we have to put a star in front of that. Right, so does that check? It does not. Oh, we have to put a star in front of that too. Okay, so that checks. So now we have a hash map. We can actually print it out and see if we have the values we're looking for. Crabs. Right? And we can do a run. Right, so at position 4 there's 1. At position 14 there's 1. At position 1 there's 2, at position 0 there's 1, 7, 1, 16, 1, and at position 2 there are 3. Okay, so that worked. And now what we want to do is just, like I said, take the naive approach, right? And just go from 0 to 16 and calculate the distance for each one. I mean, is that? First, we need to know what the largest one is. If s is greater than largest gets s, and then we can just say crabs and largest. Right, that should give us 16. Right, I forgot the star again. And 16, yep. So now what we can do is just say for I in 0 to largest. There is one at 16, but that's not going to be valid, right? That will never be. It'll be somewhere in the middle, right? It won't ever be the last one, so I don't have to do it a dot equals. Okay. What we do then is just check we can calculate the total amount of fuel. Let total fuel starts out as 0. And for each one, oh wait, no, we want to do it for each position. We want to calculate the total fuel and then save the let least fuel. All right, let's make this a function, because that way I can say least fuel is the cost of taking the crabs to position 0. And that's not going to be the least fuel, and we're going to calculate the least fuel, right? So this will take in, the cost is going to take in crabs, which is the hash map, 32, oops, right? And a position is going to return the cost. Oh, and we need to pass in the largest. Oh, no. My brain is broken here. We want to loop over the largest, find the cost that has the least fuel. Let cost equals cost of, we don't need to do 0 again, right? Cost of taking the crabs to position 1. No, position I, sorry. And then if this cost is less than least fuel, then we're going to set least fuel. Fuel is equal to the cost, right? And then we can println least fuel is this. And hopefully that comes out to be whatever number they said. Cause 37 fuel. Okay. So we're looking for 37 fuel. And we are looking, I just double checking here. We're looking what horizontal position can they align to, and we want to know how much the fuel was, how much fuel it was took to cost that. And we don't have to multiply the position by the fuel or anything like that. So we just need to print out the least fuel. So the question is, to get to position pos, given this hash map, we can just iterate over the values, or over the keys and values, right? And we looked at looking at the values, but we need the keys because the keys tell us the position and the values tell us how many are in that position, right? So if we iterate over this, we do get key value. So we can just say for key, no, let's use the actual names so we don't get confused. For the horizontal position and the number that are at that horizontal position in crabs.iter, right? We want to say if we're less than the position, hpos is less than the position, then the amount of fuel it's going to take, we need a return value. Let total equals 0. And then we'll just return total at the bottom and close that. Of course, it won't indent right because I haven't finished this yet. There we go. So if the horizontal position is less than our current position, or the position we're looking for, then we just need to say total is equal to the cost of getting there, right? Times the number that we have. So it's number times, and position is greater than hpos, so we just subtract. Else, okay, if it's equal, there's no cost involved, so we don't have to do anything. And if it's greater, then it's just the same thing, but with these things reversed. So I'm gonna do this. So this is if position is less than or greater than, right? So if it's not equal to pos, then we'll add. I was going to say hpos is less than pos or hpos is greater than pos, but that works out to be the same as hpos is not equal to pos, at least in the integer domain. All right, that's not too bad. Does it work? Does it check? It does not check. I have to pass in a reference. And we can't compare I32 with I32, but we can compare it if we dereference it. No more items. Oh, let mut. Okay, so that checks. We do have least fuel of 37. Oh, let me get rid of that print line. Okay, least fuel of 37. So this is essentially part 1, right? So we can just say this. Day 07 part 1 is this. And now I want to copy in my real input. So let's put an underscore there, and let's say real input equals, and I'm going to paste that giant string instead of reading it from a file because I'm lazy. Okay, and then instead of saying test input here, we'll say real input, cargo check, cargo run. We got a number, right? How much fuel they must spend, and that's what I did. Okay, just double checking. That's the right answer. Oh, good. That's excellent. All right, so before I do part 2, is there anything I want to do cleanup wise? No, this is pretty short. I'm starting to get nervous about what part 2 might be. Because if it gets on the complex side, we're going to have problems. Right? If this naive solution ends up being bad in terms of compute time. All right. Oh, hello. There we go. Source. Oh, I want to do a clippy, right? See if clippy has any good ideas. It does. Oh, this is for day 5, which I didn't want to do. For now, no. It did reformat my code. What did it do here? Oh, it changed. It took away the space. Okay. Git commit -m day 7 part 1. We'll push that up. All right. So what is part 2? He says nervously. Part 2. The crabs don't seem interested in your proposed solution. Uh-oh. Perhaps you misunderstand crab engineering? As it turns out, crab submarine engines don't burn fuel at a constant rate. Instead, each change of 1 step in horizontal position costs 1 more unit of fuel than the last. First step costs 1, second step costs 2, and so on. All right. As each crab moves, moving further becomes more expensive. This changes the best horizontal position to align them all on. In the example above, this becomes 5. This costs 168 fuel. This is the new cheapest possible outcome. The old alignment position 2 now costs 206 instead. Determine the horizontal position the crabs can align on. How much fuel do they spend? Okay. This actually, day 07. I mean, this means that we change how we calculate here. So we change 1 line here to get a different outcome. Right, and to calculate the thing, it's just 1 + 2 + 3 + 4. It's just standard, high school algebra. 1 + 2 + 3 + 4 + ... + n is equal to n times n + 1 over 2. Right? I mean, we know that from high school. So do I just create a second cost function and duplicate all the code? I mean, we can do that just to get the answer. Oops. I want to yank to the bottom of the thing. There we go. And cost 2. And it's just going to be I typed L. Let dist is equal to that. And instead of that, it's going to be just this equation here. Dist times dist + 1 all over 2, right? That doesn't check. Oh, I put up. That's not how you do comments in Rust. There we go. We do have 2 warnings. That's because I'm not using the cost thing. But what we can do is just duplicate all this and put it. What did I just do? What the heck did I just do? Copy all this and put it here. And then for part 2 is just this. Cost 2, and day 7 part 2 is this, and then we just take away the let and the mut here. That should check. Let's run it with our test input first. $168, right? Okay, so that was pretty straightforward. Now I was getting all nervous about what part 2 is going to be like. If we change it back to our real input, we get no errors and no warnings, and we get a giant number. That's a lot more fuel than that, right? By a factor of 1,000. All right. Oh, it is the right answer. Okay, so this was a relatively easy day. Yesterday was a relatively easy day as well. Maybe we can kick it up a notch by learning how to pass functions in. Rather than having a duplicated code here, we should be able, I don't think I've done this before in Rust. I do it all the time in C. You pass in like a callback function. And there's a way to do that in Rust as well, right? You can just say callback is a function. And what does it need to take? It just needs to take a value, an I32, and returns an I32, right? I think that's how you do it. I've watched streams, so I'm an expert. And then what we can do instead of having 2 different cost functions. Oh, you know what? Before I do any of this, let's check this in. Make sure I didn't. Yeah, I haven't changed anything yet. So this still runs. Cargo run. Okay. Clippy is still going to complain about day 5, which I'll get to that after this. I mean, we finished everything really quickly, so might as well clean up day 5 while I'm here. Git add source. Git commit -m day 7 part 2. That was very, very fast. Okay, now let's just see if we can make this happen here. So let's delete this function. And what we're going to do is have 2 different functions. So we delete one function but create 2 more. This is going to be a linear cost. And it's going to take a dist I32 and return an I32, and it's just going to return dist. Right? Linear cost, if you're going 1, it costs 1. If you're going 2, it costs 2. And then there's arithmetic, or arithmetic cost, which is the dist I32 to I32. And this is just going to be dist times dist plus 1 divided by 2. And instead here, what we're going to do is we're going to call the callback with the dist, which I just deleted. Callback with the dist. There we go. All right, so can we do that here? We pass in crabs I and call it linear dist. And crabs, oh, we have to do it each time though. Linear dist. And then instead of cost 2, we're going to say arithmetic dist. Here. And there, does that check? Oh, the file has been changed. No, I don't want to change it. Okay. Let's load it and redo all the work I just did. I guess I could have overwritten it and then just did a cargo format. I don't know why I didn't do that. So, but we can do this pretty quickly, right? This function I32 returns I32. Get rid of all this. So function linear dist I32, and I'm just going to throw it here just to be quick. Arithmetic, and this is going to be dist times dist plus 1 divided by 2, and I'll let cargo format handle that. I'll get rid of that line. Cost 2's go away and become arithmetic dist. Arithmetic dist, this is linear dist. linear dist. 2 warnings. I don't know what they could be. I'm definitely using everything. Oh, yeah, good. Thank you for the warning. I need to wrap this in the callback. That's what I missed. Cargo check. Okay, so now it should run. And it comes up with the same answers, right? Let's go back to day 7 and make sure those are the same numbers, right? 347, 449, 980, blah, 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 527. Yeah, okay, so that works. So that cleans up things a little bit. We're still looping twice here. So now we can actually clean this up as well, right? We can say for func in linear dist, comma, arithmetic dist, do this. Oops. Func. Can I do this? And then just do this, and we just have to figure out how to do this part. Okay. This is the most complicated part of it now, is figuring that out. But I think we can just do it like this. Enumerate, right? My brain has such a hard time parsing function types in parameters lists. Yeah. Hi, Epic, by the way. Thanks for joining. Yeah, so this I'm talking about this thing here. Oops. Yeah, I went too far. Yeah, if you create a separate type, you could just make that a thing, and then these have to just match the same type. There's probably an even better way to do it with like a trait. I could make a trait and then just do it that way. This is part plus 1, right? Like that. Does that check? It does not. Oh, I can't enumerate. Oh, I have to iter. Doesn't like that. It's not iterable. Can I iterate on that? Expected to function pointer found a reference. Okay, so that's, and that's probably means that part is also a reference, right? usize cannot be dereferenced. Okay. So that wasn't, so for some reason func is a reference to the functions, but enumerate gives us an actual value for part. Okay, that's good to know. So this should still run. Yeah, and it gives us the same thing, and it says part 1 and part 2. So I think that cleans up the code a lot, right? It fits on less than a page. How many lines of code is this? 42 lines of code. Well, it's going to spread out once I run cargo format on it. Yeah. Yep. So it added. So okay, 46 lines of code. Not bad. Not bad for day 7. Actually, you know, we're a third of the way in now. Almost a third of the way in. Tomorrow's a third, right? And this was a relatively easy problem to crack. I had to think about it based on you know what it was asking for, and I was trying to see, is there a way to optimize it? Do you find the mode and base it off, you know, search by where the mode of the thing is? But no, we just did a linear search for over every possible cost value and found whatever the least was. So pretty easy. Git add source, git commit -m day 7 part 2. We'll push that up, and then let me clean up day 5 so Clippy stops complaining about that. Source day 05. And it's complaining about these lines here. And it was saying do a match instead. I wish I had followed Edmonton code myself, but on the other hand, it's quite nice to watch someone solve these on stream while I'm working with Rust myself. Yeah, I mean, I do watch coding streams while I'm doing other things, because I actually, even though I'm working on something, I can still learn on the other stream. And especially, you know, with Togglebit, if you ever watch his streams, he's very animated and he gets very into what he's doing. So it can be educational and entertaining and useful to have on in the background. Let's see, what can we do? So they're saying do a match instead of, right? That's what Clippy is saying. Consider rewriting the if chain to use compare and match. So let's look up what compare does. Rust CMP integers, or I32 I should have said. So what do we have? Equal, ord, partial, equal, partial, ord. Oh, this is the compare. Maybe I want this, compare. Wow, that's... How do I turn off this? Maybe it's too narrow for the pop down to come down. But if we just compare ordering... Oh, I see. It's compare. If it's less, greater than, or equal. Let CMP equals natural. Really? I don't get this. Compares LT, compares GT. Okay, well, I mean, I can try it. You can say let compare equal natural, and we'll have to pull in, use compare natural, like that, and then use standard. Is this a separate crate though, or is this part of? Because I don't want to do it. I have an aversion to pulling in crates for advent of code. I do make an exception for regex, so. Yeah. So it doesn't know compare. Oh, I have it because I have a capital C. Undeclared creator module. So I would have to add a crate. Yeah, crate compare. I should have seen it right there. Okay, so this is actually what we're looking for, right? So let's get rid of that. And I think what they're saying here is just do a match x1.cmp x2 if it's less than x1 plus equals 1, right? And if it's greater, x1 minus equals 1. And if it's anything else, we don't do anything. Is that what they're saying? And I have to pull in those things. I did, okay. But I probably have to put ordering, right? Like that. Oh, arrow. Really? I put it here, right? Oh. Okay, maybe I don't have to do these. And then natural doesn't exist. We don't need that. Expected ampersand usize found usize. Okay. All right, so it worked. Does the test case pass? We're not using equal. The test case passes. Actually, let me double check because it says test part 1, but it's actually test both parts. Test both parts. Okay. All right. Is that simpler? I don't know. Maybe it's more visually. Let's grab 5 lines here and switch these over to Y's. I have 2 warnings. Oh, probably because of the equal thing, right? Yeah. Okay, run the test. The test still pass. Oh, I ran the run, not the test. Let's do the test. Test still passes, so let's just check the numbers are still correct here. On day 5, I got 4728, yep, and then 17717, yep, okay. So if I say cargo format, no, it doesn't reload it. Okay. I mean, it seems fine. In the beginning, I thought the rustification of certain patterns was harder to read, but nowadays I generally prefer them. Yeah, I mean, once you start getting used to them, right? After you see the pattern once or twice, your brain kind of does the translation for you. I agree with that, Epic. Yeah. So I did verify. No, I didn't verify the clippy. Okay, so now clippy's happy. That's good. So all we did here was change from on day 5. We changed the comparison less than or greater than, and in fact, you know, the ideal way to do this would be to just return a 1 or a -1 and just say x1 plus equals x1, compare that, and then the match would do it. Return +1 or -1, but unfortunately I use U sizes everywhere, and you can't have a negative U size. So yeah, I don't know if this is easier to read or harder to read than the code that was here before, but it's making Clippy happy, so that's the important part. I changed something, didn't I? No, I didn't. Okay, git add source. Oop, git diff stage. Let's just take a look at the diff. Yeah. So I added this, and then I changed these. So it's actually longer, right? No, it's still the same number of lines of code, and possibly easier to read. And then I fixed the name of the test. Okay, git commit -m make Clippy happy for part day 5. Hit push. All right, so that was that. That was surprisingly fast. Let's close out this. Let's close out that. We're going to keep this guy around. Let's take a look at our leaderboards. I don't have a private leaderboard, but on Chail I do. I am how far down? Here I am, number 10. Not bad. And on Togglebit, what do we got? I'm 9. Okay. In the top 10. Prime, I'm pretty far down, right? 32nd. Wow. And then on Sam, I'm up there. 6th. Okay, good. And I do have private stats, right? Yeah, somebody solved this in a minute and a half. If it wasn't a hard one. Yeah, this was the weekend. I skipped the weekend. I did them yesterday. But it looks like we're hitting, right around the same time. 727, 723, 725. My rank's getting better, and I think that's only because fewer and fewer people are doing stats. Yeah, you can see fewer and fewer people are doing it every day. And I think the reason is that days 1 and 2, people are you get those like in high school and middle school. Maybe they'll give those assignments out because they're relatively easy. And then as they get harder and harder, there's no point in middle school doing difficult problems because they're not going to learn anything. You want to give them problems that they can solve. So that's probably the reason for 1 and 2. But like I said, day 6 was pretty easy. Day 7 was pretty easy. I thought day 3 so far was the hardest one, mostly because of the wall of text you were confronted with, trying to figure it out. And my day 3, yeah, you can see it. Solving part 1 was 7:34, and solving part 2 was a half hour later. Whereas here it took me 5 minutes, and most of that was just futzing around.